guys, welcome back to the Point Academy. So in this video we will discuss about focal length of a spherical mirror, and also we will find the relation between focal length and radius of curvature of the spherical mirror. So let's see this figure. This is a spherical concave mirror, and you can see this area is polished, and this line is known as principal axis of the spherical mirror, and here we have focus F, and this point is known as center of curvature, and this is point known as pole and denoted by P. So this is the figure where we will find the relation between F means focal length and radius of curvature capital R. So first we will discuss about definition of focal length. The distance between the focus F and the pole P of the mirror is called the focal length of the mirror. So here we go. This is the focal length and denoted by small f. This is the pole. So now we have to show that F is equals to capital R upon 2, where capital R is the radius of curvature of the spherical mirror. So now let C be the center of curvature of the mirror. Let a ray come from parallel to this principal axis and striking this wall. After striking this wall, it come through focus point, and we draw a bisector through this point, and let this point be M. This is the direction of ray, and this angle will be theta. So this angle also will be theta, and this angle also will be theta. Okay, so this angle will be 2 theta, and now we will draw a perpendicular through M. So this point be D. Clear? Consider a ray parallel to the principal axis striking the mirror at M, then CM will be perpendicular to the mirror at M. Yes, you can see this CM will be perpendicular to this mirror. Okay, let theta be the angle of incident and this theta be the angle of incident, and MD be the perpendicular from M on the principal axis. Then angle MCP is equals to theta. Angle MC and P is theta. Clear? So, and angle MFP is equals to 2 theta. Clear? We get tan theta is equals to MD upon CD. Here you can see tan theta means perpendicular MD upon CD. This is tan theta. Clear? And tan 2 theta is equals to MD upon FD. Also you can see here tan 2 theta MD upon FD. This is the equation first. For small angle theta, which is true for paraxial rays, tan theta approximately equals to theta, and tan 2 theta also approximately equal to 2 theta. Therefore, equation first gives MD upon FD is equal to 2 MD upon CD. So MD cancel. Clear? And this implies that FD is equal to CD upon 2. This equation second. Clear? So now for small theta, the point D is very close to the point P. Clear? Therefore FD is equals to F and CD is equals to R. So equation second gives F is equals to R upon 2. Here we go. This is the relation between focal length and radius of curvature, hence proved. So now summarize of this topic. So topic is the focal length of a spherical mirror. Focal length is a small f. Definition: the distance between the focus f and the pole P of the mirror is called the focal length of the mirror. So you can see this is the focus and this is the pole P, and distance between them is small f, known as focal length. So we have to show that f is equals to R upon 2, where R is the radius of curvature of the spherical mirror. So we have to consider that C with the center of curvature of the mirror. So consider a ray parallel to the principal axis striking the mirror at M. You can see a ray parallel to this principal axis and striking to the point M on the mirror. Then CM will be the perpendicular to the mirror at M, let theta be the angle of incident and MD be the perpendicular from M on the principal axis. Then angle MCP is equal to theta and angle MFP is equal to theta. So we get tan theta is equal to MD upon CD and tan 2 theta is equal to MD upon FD. This is the equation first. For small theta, which is true for paraxial rays, tan theta approximate equals to theta and tan 2 theta approximate equals to 2 theta. So therefore equation first gives MD upon FD is equals to 2 MD CD. So MD cancel, and this implies that FD is equals to CD upon 2. This is equation second. Now for small theta, the point D is very close to the point P. So therefore FD is equals to small f and CD is equals to R. So equation second gives small f is equals to capital R upon 2. Hence proved. This is the relation between focal length and radius of curvature of the spherical mirror. So this derivation is finished here. So hope if you like this video, so please subscribe to our channel for more update. Thank you.